Hello everyone. This is the first in a series of videos going over some simple summary statistics in R. So let's begin. Now the first thing I want to do is, I have my RStudio window open and I've already opened a new R script file and I've named it in a particular way. Now we're ready to begin. So I'm going to set my working directory and that will be the first thing I do. So to do that, I'm going to go into session, say set working directory to source file location. Because I already have saved my R script in a particular location. So I'm telling R that I want all of my files from this particular analysis, from this particular time that I'm spending on the analysis, all of the files that I generate have to be saved in the same directory. So, and you see that it shows up in the console as the file path for the working directory is now in my console. So I'm just going to copy it and come back to my R script and paste it and save my R script there. Okay, so now we've set the working directory. But before even setting the working directory, I think one of the best practices is to give a small title to the R file, R script, to indicate what the file is actually going to do. So now I'm going to call this descriptive statistics warming up. Okay, so notice that if I just start typing descriptive statistics, the font is in black, and R is going to think that that is actually a command that it needs to run. But essentially what I'm writing is more a text line indicating what the file is all about, and it's something like more an instruction to myself. And we refer to such things as comments in R. So the way to tell R that this is not a command that it needs to run, but rather it is a comment, what we do is we put a hash in front of whatever text we want to type. So I put a hash down here. So I'm going to say descriptive statistics warm up. So that is a title for my R script, and to make it even more, stand out, I'm just going to put in some nice heading type indicators there. Okay, so we know that this is an R script that looks into descriptive statistics, and we're just going to warm up towards some calculations. So let's begin. So the first thing we're going to do is we're going to try and use R as a calculator. So what do I mean by this? R can just run simple calculations like Excel does. So for instance, if I want to do 2 plus 4 or 2 plus 3, so I type it here in my R script and I do Control Enter. If you use Windows, it is Control Enter. If you use Mac, it is Command Enter. So if I do that, then it runs the command that the cursor is particular. So whichever line the cursor is on, R will just run that command and show you the results in the console. So that's what that keyboard shortcut does. So I do Command Enter and it gives me the result as 5. So it can do additions, it can do subtractions. So 15 minus 9, do Command Enter, I get the answer 6 there. I can try multiplication, 45 times 35. I get an answer there. And then I can do division. I can do 600 by 15. I get an answer there. And it can also give you exponents. So suppose I want to do 2 raised to the power 5. So this symbol is an inverted V that's between 2 and 5. And you'll see that on top of the number 6 in your keyboard. So that indicates you are raising something to a particular power. So this is actually 2 raised to the power 5. So we should get the answer 32. So another way to run your command is to actually select the particular command line and click on this run button that you see here. So you could either do that, but I think over time with practice, you get more comfortable just using keyboard shortcuts. So you can do exponents, I can do square root of a particular number. So and the function for that is you type sqrt. So that is the function to calculate the square root of a number. So you do sqrt and then you open curved brackets, and you notice that RStudio is immediately filling in with the closed brackets also. Because every function, whenever you open a bracket, you have to close the bracket. That's the fundamental rule of any coding. So if I want to compute the square root of 16, I will put the number within the brackets And now I do command enter, it will give me the answer 4. Now what happens if I don't close the bracket? So if I just do square root of 16, and if I ignore that closed bracket, and if I press enter, the console shows that there is a plus symbol here instead of this other symbol that you see. A plus symbol in the console indicates that R is waiting for the code to be finished. So it expects that the code that you have typed is unfinished and therefore it wants you to finish it. So if I put a closed bracket here and now press enter, the code is complete. But it also indicates to you in the R script that there is an error here in this particular line of code. So if you hover your cursor over this into mark here, the cross sign, it tells you what's wrong. So you can go and fix it. So it tells me there's an unmatched opening bracket, which means it needs a closing bracket. So the minute I close it, the error will vanish. So you can take square roots. You can also compute log values. So if I want to get log of say 100, note that, okay, so before I type in 100, let me just type say log and oops, okay, so let me do log and open the brackets. So before I even open the brackets, you see that there's this drop-down box which pops up on RStudio. So R is indicating to me all kinds of functions that it has, which start with the word log. The most common one is log 10, just plain log. And if you notice in the yellow box here, it tells me that the way this function is typed is you do log, open the brackets, and X here stands for any number for which you want to compute the logarithm. And comma, so that's what the first, this is called an argument in a function. The first thing that you have to type in whenever you write a function is an argument. I mean, a function can have different arguments, so this is the first one. And X here is a placeholder for any number for which you want to compute the logarithm. And then you have base equals exponent raised to the power 1. So this is actually nothing but it's telling me that the log function is set to the base e, which means it is actually computing the natural logarithm. So let's try that. So if I do log of 100, because it's set to the base e, it will give me the answer 4.60517. Suppose we had log set to the base 10. So I can, in that case, it will be 10 power 2 is equal to 100. That's the exponential relationship. When you convert it into logarithm, it will become log 100 to the base 10 is equal to 2. So if I want to compute log of 100 to the base 10, I type it in this way and I press enter, and now I should get the value 2. Another function to do this is to actually just use log 10 and then say log 10 of 100, and that means you want to get the log of 100 to the base 10, control enter, the answer is 2. So you can use R as a calculator to compute all of these. Then I can also get absolute value of numbers. So if I want the absolute value of say 45, it will be 45. If I want the absolute value of say minus 2,496, then it will be 2,496. So you can use R to do these basic calculations. You can also actually use R to create objects which can take on different values. So to do that, let me create an object called, maybe I'll just call it object 1. And this can just be the number 9. Now notice what happens when I run this. It shows up in my environment as object 1 with the value 9. So anything that I create like this here, where I create give it a particular name and I say it is equal to something, that's called an object in the R vocabulary, and it shows up here. So I can, instead of calling it object 1, I could call it anything else. So then let me create another object, which is another number, say 16. Now let me run this also, so it shows up in my environment. Now suppose I want to do object 1 plus object 2. It'll go and add the numbers that are within this object and give me the answer. So object 1 plus object 2 is 25. And I can even actually take the square root of this sum. So I can write a nested command which goes like this. I want to take the square root of the number which is actually the result of object 1 plus object 2. So we all know that 6 plus 9 plus 16 is 25. So the square root of 25 should be 5. So let's check. There we go. That's the answer. So we can do that. We can also create something like a column of numbers, and we can actually add 2 columns. So let me create an object, say x. And we saw in the previous video, that to create a column of numbers, we use this command C. And suppose the numbers here are 1, 2, 3, 4, 5. Let me run this. It shows up in my environment. Let me compute another one, which is say 2, 3, 4, 5, 6. I'll run it. Now I have 2 columns which are of equal length. They each have 5 elements. Now I can actually go ahead and add these elements. So I can do x plus y. See how it shows up in my console? It adds every corresponding element. 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 4 is 7, 4, 5 and 9, 5, 6 and 11. I can do y minus x. And it will do 2 minus 1, 3 minus 2, 4 minus 3 and so on. I can do x minus y. It will all be minus 1 numbers. So you could create columns like this and you can do calculations on those as well. Then I can also do, let me actually create a bigger column of numbers. So suppose instead of numbers going from 1 to 5, I want numbers say going from 1 to 50. And then it's going to be very lengthy to type in 1, 2, 3, 4, 5, 6, 7 up to 50, right? So the key to do that, the way to do that is I'm going to create, let's say, an object A. And I want these to be numbers from 1 to 50. And what I can do is I can use the concatenate function, which is the C open brackets function. And I want the numbers running from 1 to 50 successively. So I can do 1 is to 50. 1 colon 50. And when you do this, it shows up in your environment as an object A, and it says these are all integers. INT indicates integers going from 1 to 50, or it has 50 rows, and the numbers are 1, 2, 3, 4, 5. It shows you a preview of the first 10 numbers. So if I want to see A in my console, so I'm just going to type A and do Control Enter. See, all of the numbers in A are now listed here. So this is a much quicker way to type out a longer series of numbers. Suppose instead I want numbers from 1 to 50, but I want them, suppose maybe I want numbers from say 2 to 60, but I want them in increments of 2. I can do that as well. So the command to do that is there's another one where I create an object B, and I use the function called sequence, open brackets, and I want the numbers from 2 up to 60. So 2 is the minimum number, 60 is the maximum number, and I want them in increments of 2. So this is the command. Let me do type enter, and the object here is created, B, in the environment, and you can see the numbers go from 2, 4, 6, 8, 10, 12, and so on. So that's exactly what we wanted. And I can check by printing B in the console, and this is precisely what I wanted. So I can use this function to create any sequence of numbers going up in any specific order. So if there is a pattern to your numbers, you can use this function. So suppose I want numbers going from say 5 to 100 in increments of 0.5, I can do that. There we go. That's a much bigger list of numbers, and this is a very easy way to create a huge list of numbers. And now you must be beginning to see why coding in R or programming language is a much faster way to do certain things compared to using Excel. So I can do all of this. And now what I'm actually going to do is I'm going to show you some simple descriptive statistics using any one of these objects that we are creating. So maybe we can focus on the sequence B. So let me tell you that we're going to do descriptive statistics now. and our interest is this object B. So if I want to find the mean of this object B, of the series of numbers that go from say 2 to 60, there are 30 entries in this. So if I want to compute the mean, the function is actually just mean, MEAN of B. So that's the function, and I type in the object for which I want the mean to be computed. Control enter, the mean is actually 31. If I want to find the median, I type median of B. And let's make a guess of what the median would be here. So the median is the mean of the two middle numbers, which will be the 15th and the 16th, 14th and the 15th numbers, or 15th and 16th numbers. So that would be, that's 5. Okay, so the median of the 15th and 16th, sorry, the mean of the 15th and the 16th number will be our median. So we should expect median to also be 31. So let's see. There it is. So median is also 31. Now, so I'm just going to say this is compute arithmetic mean, compute average, sorry, compute median. Now, R does not actually have a code, a built-in code to compute the mode. R does not have a built-in function for mode. So we'll ignore it for now. Then let's see, what else can we compute here? Let's look at the minimum value here. We'll do the 5 number summaries that we're interested in. So actually, there's a very interesting, a very easy shortcut to computing doing the 5 number summary, which is mean, first quartile, median, third quartile, and maximum value. And the command for that is to just say summary, open bracket, put the object that you want to be summarized, which is B, control enter, and there you see. So you have R displaying all of the values of interest for us, which is the minimum value, first quartile, median, mean, third quartile, and the maximum value. So it's a very convenient command to do that. But there are also ways in which you can actually compute the different quartiles also. So the function for that is actually called quantile. Okay. So quantile is something which actually divides your data set into equal parts. So, and you can have, so a 50-50 median is a type of a quantile. A decile, which divides your data into 10 equal parts, decile is a type of a quantile. A quartile, which divides your data into 4 parts, that is also a type of quantile. Percentile is a type of quantile, and so on. So R just has a generic function to calculate any measure of relative position, and that's given by this function quantile. So suppose I want the first quartile, which is nothing but the 25th percentile of B. I use the quantile function. I put in my object here, and I type in the number 0.25, which tells me I want the first quartile. So let's run this and check if it matches with what we got in the summary function. So first quartile, 16.5, exactly correct. So that's our first quartile. Let's get the third quartile. So for that, I use the quantile function of B, 0.75. This should be the third quartile. Let's do enter. So command enter, 45.5, 45.5. So that works out. So we are now able to compute measures of relative position also. The next thing, maybe I want to compute the variance of this set of numbers. So the command function for that is just VAR, variance, open bracket, say B, enter. The variance of this particular object is 310. To compute standard deviation, you only have to do SD of B. That's the standard deviation. So let me just comment the file. So this is variance. This is standard deviation. So let's check. The answer is 17.60682. I can double check if this is indeed the standard deviation. by checking if it is equal to the square root of the variance. So I can do square root of and copy this variance number, which is 310. So I'll write it down here. Square root of 310 is 17.60682. Another way to actually run that is to do square root of variance of B. Okay, let me type that again. It is square root of variance of B. And notice how, and variance of B is the number for which I want the square root. And I'm actually doing a nested function here to make my commands crisper. So let me run this. The answer is the same. So these are some ways. This is just a very gentle introduction. So in the next video, I will use a particular data set that is built into Excel and show you how to get some summary statistics and also plot some basic charts using that data set. So I'll see you there. Let me save this video and I'll close this and I'll see you in the next one.